Hi, my name is Rob Haines, and I'm going to talk about application security in Go. As Go is becoming increasingly popular and widely used for web applications, keeping your data secure is going to become increasingly important. In this talk, I'm going to cover some of the technologies that you can use to do this and to make sure that your data remains secure. So first, a little bit about me. So I'm currently a sales engineer for Synopsys. Synopsys is a company that provides application security tools and services. But I used to be a software engineer writing C and C++ in the telecoms and embedded area. I also got the opportunity to do some build and integration. So I was doing things which were effectively DevOps before they became DevOps. And this gave me a chance to look at tools like static analysis. So I ended up becoming the static analysis subject matter expert for my company. And I got to roll out these tools to different parts of the company in China, India, and also in the US. Now I'm a sales engineer and I help customers implement SAST. This gives me a chance to go do some travel. I cover currently Eastern Europe and Russia, as well as some parts of the UK. I first came across Go the last couple of years, and actually it's something that's being widely used in our company. It's sort of the go-to language for replacing Java when it comes to command line tools, and it's something that we're increasingly interested in. Okay, so why should you be worried about AppSec? So when we think about application security, we think about hackers, but really what is the problem we're trying to solve? Really, what hackers are trying to achieve generally is the theft of personal data. So they are trying to steal information that they can use, like credit card numbers, ID numbers, names and addresses. Now, this can obviously lead to a loss of reputation for your company. You can get brand damage and a loss of trust. While these were things which I think were really important in the earlier days of the internet, I think it's less important now. Of course, you don't want to be remembered for the company that loses that information, but I don't think it's important as the final one here, which is fines and penalties. Especially across Europe, the fines these days for not being careful with application security can be very high. So you can see here Marriott being fined 100 million, Equifax 700 million, and British Airways 183 million. I think this really is the danger these days. It's being fined a lot of money for getting your application security wrong. So how can we secure applications? Application security isn't just a single point where you should be doing something like running a tool or looking at your code. It's something that should really go all the way across the different parts of this secure development lifecycle. For example, as we're doing our requirements and design, we should be looking at threat modeling, security design reviews, and attack surface reviews. There's statistics that say that these days, a lot of issues that are security related are actually part of the design and not part of the coding. When it comes to actual development themselves, the biggest things that we can do to prevent security issues is actually education. So doing e-learning and understanding security issues, also doing peer review with people who have been security trained can help stop putting these issues in to start with. But of course, today we're going to talk about static analysis and software composition analysis as tools that you can use to double check this. When it comes to the testing phase, we have other technologies like dynamic analysis, interactive analysis, and application fuzzing. And of course, manual pen testing as well, when you're using experts to try and hack into your applications. And finally, when we come to deployment, we can have security reviews. There are also tools that you can use around this area to do things like scanning for open ports and making sure that everything's at the right patch level and that sort of tool as well. Okay, so what are the different applications we're going to be using for, different technologies we're going to be using for application security? So take this example web application that we've got here. It's made up of your own proprietary code. So this is the stuff that you write, and this is the main part that we're interested in checking. Now, nearly all code these days uses open source in some form. This could either just be libraries for helping you write your application, but also web frameworks as well. Nobody ever really writes a new thing that interprets HTTPs and gets and posts. You're always going to reuse somebody else's work to do this. And these are usually open source as well. Now, at the bottom of this application, we have potentially systems like databases or another APIs using REST. And at the top, we also have sort of our web services layer. So what different technologies can we use here? So the first one is dynamic application security testing. And this is effectively treating the device as a black box using dynamic testing after the application has been written. We have a technology called interactive application security testing, and this effectively uses an agent sitting on the application to monitor it for security. And we have protocol fuzzing. Now, protocol fuzzing might actually be something that's interesting for Go. Typically, where we have seen people using fuzzing technologies is for implementations of protocols. For example, HTTP, IPv4, IPv6, there's hundreds of them. But these have all been typically written in C. Now, Golang being a great language for writing fast, efficient code, we're actually seeing protocol implementations being written in Go now. So protocol fuzzing might be something that's very useful there. The final two, and this is what we're going to talk about for the majority of this talk, is static analysis or static application security testing and software composition analysis. And these are really looking at the proprietary code that you're writing and also the open source that you're bringing into your application. So in Synopsys, we have two tools for doing this. They are called Coverity and Black Duck. We'll have a quick look at the tools, but I really want to get across the technologies and how they work. So what sort of issues are we looking for? Now, I'm going to concentrate today on web applications. Now, of course, a lot of the things that Go are used for are also public facing, but maybe not what you would interpret as web. But anything really that's using HTTP as its transfer mechanism, using REST APIs, these are the sort of things that we're looking for. And the good place to start is the OWASP top 10. Now, there are security issues outside of this, of course, but it gives you a good idea of the things to look for. This top 10 is really there to provide a checklist of sort of things that you should be looking for when it comes to application security. And a lot of these you'll probably already come across. So for example, in the A1 section, we have things like path manipulation, SQL injection, OS command injection. In the A2, so things like weak encryption. And then in A6, we have things like stack traces and error messages. For example, if you ever come across an application on the web and it crashes and you get a 404 error message, not 404, a 500 error message, sometimes it will print out the stack trace. And that information is not a good idea to give away to hackers because it tells them about the application. It gives them inside information. So if you haven't looked at these already, it's worth looking it up. The OWASP top 10 is updated on a regular basis. And if there's one message I can get across from this talk is that just training and just being aware of these different issues and how to prevent them in your code will make a big difference, regardless of if you use tools. So when it comes to the OWASP top 10, the technologies we're going to talk about, static application security testing is going to cover A1 to A8 and A10, but software composition is going to cover A9. Okay, so let's talk about static application security testing, or SAST. I'm going to call it SAST from now on, just to save some time. But you might also have heard of this as being static analysis. So how does it work? So when you're running SAST, which is run on your source code, in most cases, some tools do actually run it on bytecode for languages like Java, but in general for Go, you're going to be looking at source code. The code is decomposed into what we call an abstract syntax tree, or AST. And this is really an internal representation of your code. So you can see here in this particular function, we have a while statement and a return statement. And then within the while statement, we have a comparison. And then inside that while, we'll have a branch. And you can see here how the code is decomposed into this tree. Static analysis works by iterating through this tree and finding issues as it goes. Now, I've used the word checkers here, but in Go, this is what we would call a linter. And actually, Go has very good sort of linting abilities, and I would strongly recommend, we'll talk a little bit about it later, strongly recommend that if you're not using the Go linters now, do use them. They are very good compared to other languages, and it's definitely worthwhile getting used to that, using them. So these checkers or linters will walk through this tree and try and find an issue. I always take an example here from C because it's an easy one to understand. Imagine you are looking for resource leaks. So in C, you're going to use a malloc to allocate some memory and then a free to release it later. So as we're walking through the tree, we're going to look for any case where there's a malloc statement. And then once we've found that, we're going to go through the tree and look through all of the different branches of the tree to see if we can find a free. Now, if we find a free on every single branch, then good. But if we don't find a free, then we can highlight the branches where this has not happened and point these out to the developer. Now, because we're working methodically through this AST, it allows us to test effectively every single path in the code for whatever your linter or checker is looking for. So you can see here that as we go through, there's lots of different paths as we're going through the code. And effectively, this allows you to test all of the code. And now, if you're looking at writing unit tests and you're trying to get to that magic 100% path coverage and condition coverage, you know that that's a lot of work to do. Now, I'm not saying this is replacing unit testing, but it works because it does this and goes through every single path. It's a good way of checking that every path of your code, however unlikely it is going to run, is finding, and we can find issues in that. Okay, so it sounds fantastic, but what are the limitations of this? So static analysis can be prone to false positives. Now, it's important to understand what a false positive is. It's where the tool gets it wrong, meaning that what the tool shows is not a true positive. That means it's not a real issue. Now, it's important to make sure that when you're rolling out static analysis to a development team, they understand exactly what this false positive means. It doesn't mean that it's wrong, but I don't want to fix it now, or I don't think that's ever going to happen because it's down a path that is unlikely, given code elsewhere, ever to go down. These are what I would call intentional problems, and then you can always mark those as, no, this is genuinely a bug, but it's never going to go wrong. Now, the reason I feel so strongly about this, in one of my previous companies, we managed to partially take down a phone network. I won't say who it was, but it was in a mouse-based theme park in the US because somebody had marked something incorrectly with our static analysis tool. It was a problem which they thought wouldn't happen because they didn't understand what the false positive was, and unfortunately it did go wrong, and there was a big problem. So I won't talk about that anymore, but it's important to make sure that everybody understands what the false positive is. Static analysis can be slow for very large code bases. Modern software development really is focused on being able to commit your code, run its tests, run any analysis quickly as part of a pull request or as part of the CI/CD system. We can analyze code bases, huge code bases. We have customers who have 15, 20 million lines worth of code in a single code base. And of course, that can take a long time to analyze. So for those cases, we tend to run it out of band, meaning that we don't run it as part of a CI/CD system. But for languages like Go, where the code bases tend to be smaller, yes, you can run it as part of your CI/CD system. And as long as you're willing to accept maybe a 5-minute delay, then that's okay. This would also be something that you would decide when you saw how long it took to run. And finally, static analysis can't find all quality and security issues. Issues around configuration, maybe the way that you've set up the web server or something like that. Not all static analysis can find these, but it is getting better. You'll find that linters and our checkers are now looking not just at code, but also at configuration files. Where you have designed some project badly in the fact that there is a security hole there that's nothing to do with the code is written correctly, but it's just the logic is wrong. And also dynamic issues, so things which have happened by virtue of runtime effects. Doesn't affect Go so much, but some languages where you're not mutex locking and threading issues can be a real problem. So before we talk about the commercial tools, I just want to say that static analysis for Go is pretty good. You actually have hundreds of linters which are already written. The false positive rate on these is usually very good. Now, of course, if false positive rates are too high, developers tend to ignore the results and don't use them. It's the same sort of thing that if you're driving down the motorway and there's signs saying slow down, and you never actually come across an accident or never come across any problems, you tend to ignore them. Same with checkers, same with linters. If they report things too often, you ignore them and switch them off. So I would advise you that you go and look, if you haven't done already, go and look at Golang CI, and this is a wrapper that allows you to select different linters that have already been written, easy to configure, and it gives you a consistent output. In terms of security focus, which we're particularly interested in today, you already have the GoSec project, which looks for various linters, various issues in security, and you can use this to find security issues free of charge. Now, of course, I'm here to talk a little bit about the commercial tools as well, and what is the difference really between the commercial tools you have and the open source ones. So the commercial tools are looking at sort of more complex issues. So we're talking about full data flow analysis and a complex presentation of results. We also tend to have more workflow tools and CI/CD integrations, IDE plugins, and reporting as well. Usually the workflow is really what people want to make sure that we are enforcing quality and security across lots and lots of different projects, not just setting it up for running for one or two developers. And finally, we typically focus more on security and OWASP top 10 issues. Okay, so let's have a look at a couple of examples. I've got my server up here. I'm just going to bring up and show a couple of these. What we really want to show, I'm just going to make that a little bit bigger. So what I wanted to show really was the detail that we can go down to when it comes to looking for security issues. You can see on the right-hand side here, we are looking for a journey between what we call an untrusted source or tainted source all the way to where it might get used. And you can see here that we actually go through a number of different projects. That's a number of different Go files, and these might belong to different projects or different dependencies. So I'm not going to go into a lot of detail on this problem here, but it's really where we are getting data from the outside world, and you can see here we can actually drill down into the stack trace and go all the way down, and it shows you all the details relevant to the actual lines of code. So we can go down, drill all the way down there and find out where this data is coming from, and also where that data is being used later on. So you can see this is being used. And what we're looking for in between there is some form of sanitization. Now, I don't think this particular problem is actually exploitable, but it's just a good example of the depth of analysis that we have in the commercial tools. Now, commercial tools also have sort of quality linters as well. And I always like to show this because developers love it. I used to find these sort of problems all the time, and that's what we would call a copy and paste error. Now, I've had a look to see whether there's an equivalent linter already for Go. There are some similar ones, but nothing that quite looks like this. So you can see here that we have a piece of original code, and you can see that it's got rename pattern here, and then rename pattern here. But we've copied and pasted this, and I'll put my hand up and say this is something that I've done before. And we've changed that to rename replacement, but we've not actually checked what the string that we're checking here, the length here. And this is something that's really easy to do. You can see here that this piece of code has probably been copied 3 or 4 times. Somebody's sent you a message on Slack, or somebody's texted you or something. You've got distracted and you've forgotten to do the change here. So our commercial tools have a lot of these sort of checks where we're looking even at statistical analysis. We're looking at the returns from functions, how many times that you've looked at the return from a function, have you taken an action based on that? And then maybe the next time you look at that function and you haven't done, we'll pick that up and highlight that to you. Okay, so that was a quick look at static analysis. So now we'll move quickly on to software composition analysis, or SCA. And this is really about looking for issues in your open source. Now, we all use open source. It's something that I don't think we could do without these days. We use it a lot, and it's very useful to us. I mean, we wouldn't be writing all this stuff from scratch. So how does this get into our projects? Mostly it comes from direct dependencies. So this would be something that you have your Go mod file where you define what exactly you want to use, but also side installed packages. Again, Go didn't really have a proper package manager when it first started. So, you know, it might be the case that you have open source, which you've just downloaded from somewhere, obviously usually from GitHub, and you've checked in as part of your code base. And maybe you've modified it as well. The source, it might also be the case that you've copied individual source files from those open source packages. And this is quite often the case when you want to just use one part of an application rather than the whole thing, and you don't want to compile and potentially link all that stuff together. And also libraries. If you're using mappings for a C library, you're going to link that C library in as well. Now, the real risk from this open source is, finally there we have containers as well. If you're storing all your stuff into a container to be used for later testing, that's going to also bring in open source that you might be reliable for. So what are we looking for in this open source? We're really looking for the same issues that we talked about before. But instead of actually analyzing the source code itself, we're looking to highlight known issues that have already been discovered by somebody else. And once we've found those, of course, we can change the package or potentially do a workaround to mitigate them. I'm not going to cover it today, but also licensing is important. Licensing of open source can be tricky. In the Go ecosystem, it's not really that much of a problem, but in some other ecosystems where you have licenses which prevent you from using that software unless you open source your whole application, then this might be more of a problem. It does occur in Go, but not to such a large degree as other languages. So we use these different ways of getting open source in, and our tools can help actually scan all these things. So we look at the dependencies, we look at the file system, we look at each individual source file for snippets of open source. We can use binary analysis to look at linked-in libraries, and then also scanners on Docker to look at the containers. So we found all our open source. How do we know it's vulnerable? Now, for most tools that are used, the open source ones, they're going to get their information from 2 places. First of all, maybe from security advisories, and then also the National Vulnerability Database. And this is where we get things like CVE numbers. And then these normally go to the developer. Now, there is problems with the National Vulnerability Database in the US. It can sometimes take 3 weeks or longer to actually get information into there. And then at that point, it's maybe not even complete. It's maybe reporting the wrong versions, and also maybe doesn't have any detailed information. Now, there are tools like Dependabot. I'm not going to talk about it in detail. These are really good, and these take information from things like GitHub, but they are really only looking at one source. So as long as it's reported in GitHub, then you're fine. Now, the tools that we have in Synopsys actually take information from all these different places and allow you to find information quickly. So while it might take a long time to get what we call a CVE number from the National Vulnerability Database, the Black Duck stuff can respond really quickly and help you provide more information, accurate information, and also workarounds and detailed information. So just to talk a little bit more in detail about that, we had a recent example where something had been reported by Apache, and they had said versions, I think it was 1.1 and 1.2 were vulnerable. Our own Black Duck security team had looked at this, and they had discovered that actually version 0.9 and 0.8 were also vulnerable. So we let Apache know, responsible disclosure. The Apache site was updated in a couple of days, so that was great, the information was there. The National Vulnerability Database in the US were told on the same day, and it took them 6 months to update. So using the National Vulnerability Database as your single source of truth is not a good idea. That's why our Black Duck tool actually uses both these security advisories, security companies, researchers to provide detailed information. So let's have a look at the sort of information that you get out of these tools. And also want to say at this point, just because we have a vulnerable package doesn't mean that your apps are also vulnerable. Quite often, some packages have lots of vulnerabilities. I'm going to take the example of the Linux kernel. That may have like 200 vulnerabilities in it, but that's not necessarily for all of the parts of the kernel. You might be not using a driver which has a vulnerability. Therefore, you don't need to take any action. The same is true with some of the larger open source packages for web applications. There might be a vulnerability in some templating function, but you're just using a REST API and it doesn't apply to you. So whenever it comes to looking at security results, it's important to actually go through and look at what is being created, what vulnerabilities are there, and whether or not you actually need to fix them. So in this particular case, I took a Go package here. There's only medium vulnerabilities, and only one of these actually has an exploit. So you may need to mitigate that, but the other ones you don't need to go through. So tools like Black Duck help you understand this by giving you lots of information on how to fix it, also information on workarounds. Maybe there's a way you can actually fix this without having to upgrade the package. Now, upgrading the package, of course, means you have to go through testing, and maybe even that the interfaces have changed and you actually need to do rework. So in some cases, having a workaround can be a good thing to do. So finally, that we can put workflow around this as well. And this is really one of the big differences with commercial tools, is the fact that we can put workflow around issues. We can actually specify whether you need to fix them, and also look at differences. So we can scan this once. You can actually look at the issues and say, well, actually, no, I don't need to fix these. You can scan it again and look for changes, see if there are new packages that are being used and anything that you might need to fix there. So you've gone through, you've looked at all of your security vulnerabilities, you've fixed them all. Is that it? Well, no, not really. The whole thing about known vulnerabilities is that at some point they have to be discovered. So when it comes to releasing a piece of software, as soon as it's gone live, there may still be vulnerabilities in it, and these might be discovered afterwards. So tools like Black Duck will monitor your bill of materials. That is the list of all of your open source, and it will talk back to our knowledge base. And if there are new vulnerabilities, we will find these and send these. The guy's running there because he's panicking because of his new vulnerabilities. And of course, we can alert you by these via email, of course, but also we find that we get a better response if we talk to people on Slack or Teams as well. Okay, so thanks for listening. I'm just going to have a quick wrap up. Who should be using SAST and SCA? Well, everybody. There are good free tools available now, and you should be using them. Use the Go linters and use tools like Dependabot. Commercial tools are going to be typically used by companies who want to enforce a standard across a company. They maybe need support for more than just something like Go, maybe Java, C#, and mobile languages as well. And they need support for many different web technologies and frameworks. And finally, which is the best technology? Now, the best technology is actually the developer. Making sure that the developer is trained on security will actually be a much bigger benefit than using these tools. The tools are great and they will catch things, but having people know this information and actually train on the OWASP top 10 is a very good thing. Now, Synopsys can do training courses. There is plenty of free information out there as well. Finally, if you want to know more about Synopsys and our products, you can obviously contact us. We have our partners in Russia called Rainbow Security. They're based out of Moscow. And of course, outside of Russia, you can contact our normal sales team. I won't talk any more about the sales team. Thank you very much for listening, and I hope you enjoyed the talk, and I'm quite happy to answer any questions. Thank you.
Okay, Rob, thank you very much for your talk. As I said before, I'm the person responsible. Your talk is on our conference, you know, and as I mentioned before, it was at least 2 times in my life, and then it would be cheaper to bring tools like Synopsys tools or something like this to our routine rather than deal with consequences. So, do we have any questions at the moment? Looks like looks like we don't have any questions in chat, in text to your talk. So would you be able to go to the special chat? And probably people who are waiting for you in this special chat to discuss your talk.
Yeah, that's no problem. Thanks very much for the opportunity to do the talk. I'm going to say, just in case anybody's still watching, the one thing that we wanted to get over is use the free linters. Even if you don't buy a commercial tool, use the free linters. They're very good for Go. Okay, thanks.
Thank you very much.
No problem. Thank you.